The Arctic is melting, and fast. Every year, the sea ice that covers the top of our planet grows and shrinks with the seasons. But satellite data shows a dangerous trend. Both the summer minimum and winter maximum are shrinking more and more each decade. Thick, multi-year ice is disappearing, replaced by thin, fragile sheets that don't last through the summer. As the ice vanishes, the ocean beneath absorbs more heat, which causes even more melting. This creates a feedback loop that's speeding up climate change. The consequences don't stay in the Arctic. Melting sea ice changes ocean currents, disrupts the jet stream, and throws off global weather patterns. Heat waves, floods, and even freezing winters can all be linked to what's happening at the poles. NASA satellites like ICESat-2 track these changes in real time, helping us understand how fast the Arctic is changing, and what it means for the rest of the planet. True or false? Arctic sea ice has remained stable over the last 40 years. False. Satellite data shows a consistent decline in both summer and winter ice levels since 1979. What percentage has Arctic sea ice declined per decade since 1979? – 13%. Fill in the blank. The Arctic is warming about blank times faster than the global average. Four. Fill in the blank. Arctic sea ice reaches its lowest extent every blank. September. Which satellite mission monitors Arctic ice thickness with lasers? ICESat-2. If sea ice melts at a rate of 0.75 million square kilometers per decade, how many years would it take to lose 3 million square kilometers? To figure out how long it takes to lose 3 million square kilometers of sea ice, divide that by 0.75 million per decade. That gives you 4 decades, or 40 years total. True or false? The Arctic is warming faster than the global average. True. Fill in the blank. Bright, reflective sea ice has a high, blank. Albedo. What type of ice is more likely to survive multiple summers? Multi-year ice. Fill in the blank. NASA's blank satellite measures ice thickness using lasers. IceSat 2. True or false? Sea ice helps reflect sunlight and keeps the Arctic cool. True. If Arctic sea ice drifts at an average speed of 10 kilometers per day, how far would it move in 3 months? To find out how far the sea ice moves, we start with its drift speed, 10 kilometers per day. Then we multiply by the number of days in 3 months, which is about 90. So it's 10 times 90, giving us 900 kilometers. That means the ice could slowly drift almost 1,000 kilometers across the Arctic in just one season. Which of the following is not a consequence of melting Arctic sea ice? Rising global sea levels. Sea ice melting doesn't raise sea levels, but its loss does trigger indirect changes like land ice melting. Fill in the blank. Loss of sea ice contributes to a climate feedback, blank. Feedback loop. If a sheet of Arctic ice travels 720 kilometers over 60 days, what is its average daily drift speed? To figure out the average speed, we start with the total distance the ice traveled, 720 kilometers. Then we divide it by the time it took, which is 60 days. That gives us 12 kilometers per day. So on average, that sea ice was drifting about 12 kilometers each day across the Arctic. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, Brainy friends.